This is an inquiry into natural perspective, how the eye works, how vision works, why it is that we see what we see. So does perspective only belong to the domain of art and geometry? I don't think so. Is it not more a direct and immediate consequence of the natural phenomenon of light and optics as we sense and experience it with the direct vision of our eyes? And is that not the same experience shared by everyone and a part of this reality? Yes, so what do I mean by reality? Well, quite simply, it's lived life. The reality is that we are sentient beings with memory. We can remember things. We can reason, founded upon our senses. We have active powers of causation, so we can do things or not do things as we choose. And we're in a mind-body experience of a real external world of substance. That it's a reality that we all share, I think. So, let's dive into this a little bit deeper. So we have tangibles and visibles, objects of touch and objects of sight. They are both objects of our reality, in my opinion. And as you can see from this picture, both exist. The Grand Canyon is real, I'm real, and this picture is real. Yeah, so tangible objects, they are real substance, so real physical matter that can be seen, touched, smelt, heard, tasted. I have there a cardboard box, if you like, cut in half a cardboard box. I can knock it, I can lick it, I can do all kinds of things with it. So that's a familiar experience in everyday life that, we can touch objects. It's also the world of construction and building. So the faces you see are perpendicular to each other. There's the edges. These are all 90 degrees. And this is what's used in construction. And that's the world that we know and we've learned. It's the geometry of touch. Now, visible objects are the direct and immediate objects of sight, the extended figure of lines and surfaces that are directly in our field of view, and that are differentiated by light and colour. Now, they're generally an unfamiliar experience in daily lived life. We think we see them, but we'll see shortly that we actually don't. And this is a world of light and vision. And this world seems to be different, and the geometry of it is different from the geometry of touch. It's coined the geometry of visibles by Thomas Reid. So this is a cardboard corner, so a corner of a cardboard box basically. It's been cut out. Well, you're looking at it from the outside now. It's only got 3 sides though, although each side is a perfect square. It's not a full box because I've only taken away, if you like, a corner of it. Yeah. Now, depending on where you are, this looks like a fairly normal object, and you can all see that it's 3-dimensional. It's perpendicular, each of the walls. They're all 90 degrees. It basically has these three faces, and I've drawn a triangle in between the lines. So just and they're if you like equidistant. Or it's an equilateral triangle. But now you're kind of looking at it in the normal perspective, and you can see that it changes its shape depending on the situation of the eye. In this case, the camera. But if you do it yourself, you'll have the same visible sensations or experience. Depending also on how far away the object is, it becomes more curvilinear or more spherical if it's closer to you. In this case, if it's closer to the camera, and you can move it around and see that it's actually changing shape. Sometimes it changes back to what it really is or what you think it really is. Yeah, so interesting effects with a corner of a box. If you look through a hole in the corner of that box, then you can actually see the spherical triangle if you attend to the periphery. Now, learning by touch is something that we did at an early age. So as children, we play with, objects and figures. We put them in our mouth, we move, we turn them, we orientate them in all kinds of directions, and view them from all kinds of different angles. Now, these are real solid objects. They're three-dimensional objects with a real substance, and they occupy a space in our reality. These space is such that no two bodies can occupy the same space. Now, as adults, we have associated the tangible object with the continuously changing visible figures that are presented to the eye, and we generally ignore what we see. And what we see depends on the relative situation of the object and the eye. And what we see are basically real surfaces. So we see 2D objects of light and color that occupy a space, a surface in our reality. And the important distinction here is that two visible objects can occupy the same space, as opposed to two tangible objects which can't occupy the same space. Now, in the words of Thomas Reid, since the visible figure of bodies is a real and external object to the eye, as their tangible figure is to the touch, it may be asked whence arises the difficulty of attending to the first and the facility of attending to the last. Well, it is certain that the first is more frequently presented to the eye than the last is to the touch. The first is as distinct and determinate an object as the last, and seems in its own nature as proper for speculation. Yet so little hath it been attended to that it never had any name in any language. And because he's so damn good at writing, here's another one. That's some words from Thomas Reid. Nature intended the visible figure as a sign of the tangible figure and situation of bodies, and has taught us by a kind of instinct to put it always to this use. Hence it happens that the mind passes over it with a rapid motion, to attend to the things signified by it. It is as unnatural to the mind to stop at the visible figure and attend to it, as it is to a spherical body to stop upon an inclined plane. We pass from the sign to the thing signifies with ease and by natural impulse, but to go backward from the thing signified to the sign is a work of labour and difficulty. There are other external things which nature intended for signs, and we find this common to them all, that the mind is disposed to overlook them and to attend only to the things signified by them. Yeah, so what do visibles and tangibles have in common? Well, one of the things they have in common is that they both exist independently of us or of our minds. They are real and they exist irrespective of whether we experience them or not. So whether we are actually physically there or whether we see them, they still exist. If that should be doubted as respect to the visibles, then just think of a viewpoint, and you with your buddies, and one of them will say, come over here and look at this, and you can go over and have a look at exactly the same thing that he's seeing, the same visible images in your field of view. And the very fact that you can do that and go away again and somebody else can come shows that these visibles exist, whether you're alive or not. Yeah, and another thing that's common to both is the fact that they have figure and extension. By that, it means a shape and some extension in space. So they're both made of lines and surfaces and of changing shape and color. The only difference is that visibles are not solids. They're only lines and surfaces, whereas tangibles are solids. And all these changing shapes and colors are the things that make up the geometry of the visibles and tangibles. So why is this never talked about? Why is visible figure never factored into any of the physical and mathematical theorems and equations that we're taught? In the words of Thomas Reid again, nothing shows more clearly our indisposition to attend to visible figure and visible extension than this, that although mathematical reasoning is no less applicable to them than to tangible figure and extension, yet they have entirely escaped the notice of mathematicians. While that figure and that extension, which are objects of touch, have been tortured 10,000 ways for 20 centuries, and a very noble system of science has been drawn out of them, not a single proposition do we find with regard to the figure and extension, which are the immediate objects of sight. Yeah, so what is the definitions, if you like, of geometry of touch and vision? Well, the geometry of touch measures the proportions and intervals of tangible figure and extension of objects and or parts of those objects with respect to each other. So we are measuring an object and looking at its individual parts, and we're measuring these individual parts. The geometry of vision, on the other hand, measures the proportions and intervals of visible figure and extension of those objects or the parts of those objects, and it's always with respect to the eye in a particular situation, i.e. in a particular position and looking in a specific direction. Yeah, so how does our direct natural vision work? Well, the question that I asked myself, and the question Thomas Reid asked himself, is does the eye register visible objects as if it were at the center of a sphere, looking outwards and viewing those visible figures and extension on the inner concave surface of a sphere? Yeah, so what facts do we have that can help us understand this question or find an answer to it? Okay, so fact number one is that light travels in straight lines. If that's doubted by anybody, then let them try and cast a curved shadow with a stick, and they'll soon see that it's futile to believe otherwise. Now, direct vision is caused basically by light hitting the eye from the object, and we are assuming that both the object and the eye are in the same medium. Now, refraction happens when light changes between one medium and another, and it happens at the boundaries of those mediums, i.e. if you're going from air to glass or air to water. But light travels in straight lines in the mediums before, during, and after those directional changes. Light is not continuously bending. It can be made to continuously refract in a curve, as seen by laser experiments through water. But that's the refractive angles set up such that the light beam remains in that curved path of water. So any light that does that or is lacking luminosity will never reach the eye and can never be seen, so basically plays no part in our direct vision. Basically speaking, the direct vision is like the last mile of your internet connection. A light goes straight into your eye, and it does that in a straight line. Good. The next fact is that the eye is globular, so it's globe-shaped. It's an oblate spheroid. Anybody can Google eyeball to prove that to yourself. You'll see lots of images. If you should really doubt it still, then look into the eyes of your partner or your dog or whatever, and you'll see those little globes. Now, should it be argued that for whatever reason that the eye is changing its shape so that the retina is no longer a curved surface but some kind of flat plane, then people should basically count the flickers of the eyes per second to recognize that that would be nonsense and impossible. So your retina is a curved surface, and that's where light is impressing images onto. Yeah, so another fact is that the line of sight is also always straight. If you doubt this, then try and look round a corner. You'll find that you can't. Nobody can. Now the retina is on the inside concave surface, if you like, of the sphere, with the center of the eye at the center of the sphere. And the line of sight is basically the green line that extends out from the center outwards. Now, if you're standing perfectly normal and relaxed and looking straight ahead, then that would be in the general direction that your nose and your knees are pointing in. Now, we'll see later again that this line of sight, ties into the definition of eye level and what a horizon means, and then how perspective fits into that. Yeah, so that's a fact as well, that visual rays impact the retina. As you can see in this diagram, the retina is at the back part of the eye. And it's important to note that the visual rays basically enter the eye, converge, cross each other, and then fall on the retina on the back part, just the same way a pinhole camera or camera obscura would do. Now, the angles made on the retina are the same as those on any concentric circle with a radius that is drawn between the eye and the object. So the circular line to the right of the eye is exactly the same angles and proportions as the image that is on the retina, as I hope you can see from this diagram. And the other important thing is that any rays or straight lines crossing that circumference would be perpendicular to that circumference or to the boundary surface, because the sphere or the circle is in fact equally curved. And again, in the words of Thomas Reid, now this material impression made upon a particular point of the retina by the laws of our constitution suggests two things to the mind, namely the colour and the position of some external object. That it should suggest colour and position and nothing else we can resolve only into our constitution. Whatever it is, we shall call it the material impression, remembering carefully that it is not an impression upon the mind, but upon the body, and that it is no sensation nor can resemble sensation any more than figure or motion can resemble thought. The figure he perceives is altogether external, and therefore cannot be called an impression upon the mind without the grossest abuse of language. If it should be said that it is impossible to perceive a figure unless there be some impression of it upon the mind, I beg leave not to admit the impossibility of this without some proof, and I can find none. Yeah, so when we start to look into the geometry, this is the only diagram you will really need to know and understand, and I'm going to dive into this in more detail in the next video. It's basically simple lines, planes, a circle, and an eye thrown in for good measure, pun intended. It's all about this diagram that shows basically a plan view, or a side view or a profile view of a Euclidean construction, and it also has the added circle that you can see on the left hand side, which will describe to us how the eye actually sees those things. And that's what we'll do in more detail in the next part. And once again, Thomas Reid in his words: when the geometrician draws a diagram with the most perfect accuracy, when he keeps his eyes fixed upon it while he goes through a long process of reasoning and demonstrates the relations of the several parts of his figure, he does not consider that the visible figure presented to his eye is only the representative of a tangible figure upon which all his attention is fixed. He does not consider that these two figures have really different properties, and what he demonstrates to be true of the one is not true of the other. But before we finish this part, just one small information about words. When you hear or see the words appear, apparent, disappear, then its general common meaning is to come into view or to come into sight. But in geometry, anytime we use those words, we mean the angles subtended at the eye by an object or objects of sight. And as I said, we'll go into that in more detail in the next one, but that's something to think about in the meantime. Thanks for watching and listening.